Hey Geometry, we're going to continue on with doing some proofs with some triangles, using some of those different methods we've learned so far. So this first one, we're not actually focused on doing any flow proof or whatever. We're going to do a 2-column proof for, that's going to be our focus throughout all this. So given that GH is congruent to KJ, so GH, KJ, and HL, JL, so HL is congruent to JL, and L is the midpoint of GK. Well, we're going to be able to pretty quickly show that those are congruent, so you can kind of see we're headed towards side. Let's go ahead and make that proof. So I'm going to pause here and speed through. All right, so we got our given down. So then we can say that segment GL is congruent to segment K. I'm going to go KL just to kind of match the matching components, but it doesn't really matter. KL, and that is the definition of midpoint. Abbreviate this definition of midpoint, and so now we can say that triangle GHL is congruent to triangle KJL through the side postulate. All right, the next one, write a 2-column proof to show that triangle QRS is congruent to STQ, given that RQ is congruent to TS, so we're going to know this much, and that RQ is parallel to TS. Okay, so we've got parallel, so we mark those with a couple little arrows. So we've got RQ is congruent to TS and RQ is parallel to TS. So let me set up this proof and we'll continue from there. All right, here we go. We got our given. So we've got those segments are congruent. What about this parallel business? Well, what we can actually do with these two being parallel, and then if we can think of this as a transversal, we can show that these angles are congruent to each other. So I know that angle RQS is congruent to angle TSQ, and that is from those are alternate interior angles. If I kind of continued this line on and this line on, and those would be alternate interior angles of a transversal going across a couple of parallel lines. And so that's alternate interior angles. All right, so we've got a side and an angle, and then what we can do is we can actually show this side is congruent to itself. So segment QS is congruent to segment QS because of the reflexive property. And so now I've got a side, an angle, and a side, a side, an angle, and a side, so we can show that triangle QRS is congruent to triangle STQ from side, angle, side. And that's our shortcut for that proof. All right, and then the last one, extreme sports, the wings of a hang glider shown to appear to be congruent triangles if FG is congruent to GH, so FG here is congruent to GH, sorry, kind of dark there, and JG bisects this angle, FGH, prove it. So this segment here, oh, is that showing up at all? Bisects this. I'm going to probably have to redraw this. Prove that those triangles are congruent. So let me pause and get this one started. All right, so I've added a picture over here to make this a little more visible and written down our givens. So this JG bisects FGH. So FGH bisects that. We know those two angles are congruent. So angle FGJ is congruent to HGJ, to angle HGJ, and that is the definition of angle bisector. And so then we can say that we have a side and we have the angle, and so we can get this other side is congruent to itself. So we have segment GJ is congruent to segment GJ from the reflexive property. we can then say that triangle, we can use side, angle, side, so triangle FGJ, right, the way they wanted us to, FGJ is congruent to triangle HGJ using side, angle, side.